Hello everyone. In this video, let's discuss how to write a program for path sum. Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. And leaf is a node with no children. So here they have given an example. Let's take an example. So here they have given a binary tree. In this binary tree, we have to find whether the path gives the target sum value. If it gives, we have to return the value true, else we have to return false. So here 5 is the root and it has two children 4 and 8, and 4 has only one children, that is 11, and 11 has two children 7 and 2. Similarly, when you go for the node 8, it has two children 11 and 4, and 4 has only one children, that is 1. So here we have 1, 2, 3, 4. 4 paths we have. Out of these 4 paths, if any one of the path gives the sum value as the sum target, then we have to return true, else we have to return false. So here 5 plus 4 plus 11 plus 7 doesn't give the target value 22, so this will not be considered. 5 plus 4 plus 11 plus 2 gives the sum value as 22, which is equal to the target sum, so we are returning the value called true as the output. The second example, they have given 1, 2, 3. So the target sum is 5. So this path gives me the sum value 3 and this path gives me the sum value 4. We will not get the target value as 5, so we have to return false. Now let's discuss the logic in detail. So here they have given a binary tree. So for this we have to find the logic. First let me write the logic and then I will trace the code and show you so that you can understand this very clearly. So obviously whenever we are solving a problem, we have to solve it with the help of a recursion. So here let's take the method which they have given, public boolean has path sum. So here we have to find whether this method gives true or false. That is why we are giving the return type as boolean. They have passed two arguments, which is tree node, root, and integer target sum. So this is the method they have given. We have to complete this method. Okay. So here first what I'll be doing is I'll be calling one more method. Okay. So let me call a method called helper. So here I am going to pass three arguments, which is the root and the target sum. Along with target sum, I will be passing the value called 0. So here I have to add values of all the nodes, right, so that I can get to know whether the path sum value is equal to target value or not. Initially I will be passing the value called 0. So whatever this method is returning, that has to be returned. So return, I will be calling this particular method. Now let me define the method called helper. So this method has to return me either true or false. So I will give the return type as boolean, public boolean. So helper, the method name is helper. Here I have passed three arguments, which is tree node, root, target sum, along with this sum. I will give the sum value as 0 into sum. Okay. Now we have to try the base condition. So what is base condition? If root is equal to null. If root is equal to null, it states that the tree is empty. I cannot find path sum. So directly I can return the value called false. Okay. In case if the root is not equal to sum, what I have to do is I have to take the value from the particular node and I have to add it with the sum variable. So sum plus equal to root dot value. So I will take the value from the particular node and that will be added to the sum value. Now we have to find whether we have got the sum value which is equal to the target sum or not. For that we have to write a condition if root dot left equal to null and root dot right equal to null. Along with this we have to find whether the sum value equal to the target sum. Sum equal to target sum. So if it satisfies the condition, we will return true, saying that we have a path sum value which is equal to the given target sum. If the condition is false, we have to go for the recursive call. Just either I have to go for the left child or right child. For that, I will be writing a condition boolean left is equal to helper root dot left target sum and the sum value. Similarly, I have to go for the right child. So to go to the right child, I have to call one more recursion. Boolean right equal to helper root dot right comma target sum comma sum. Fine. Finally, I have to return left or right. If any one of the condition is true, obviously we have got the path sum. So if any one is true, we have got the path sum. That's why I've given OR here. That's all. This is the logic of the program. Let's trace the code now. So here I have a method called path sum, and I have passed two arguments, root and target sum. So root is having a value called 100, that is pointing to the location 100, and target sum. So let's take the target sum value as 22. Fine. So here I am calling a method called helper. I am passing three arguments. So let's take a method helper. First is root, that is 100, target sum value 22, initially sum value is 0, which means currently root is pointing to this particular node. Fine. Now I have to check the base condition. Root equal to null? No, condition is not true. Then I'll take the value from this particular node, that is 5, that will be taken, and that will be added in the variable called sum. So initially sum value was 0, now 0 plus 5, which is 5. Then I have to check whether I have reached the leaf node or not. How can I know whether the node is a leaf node? If the left child and the right child is null, we can say that it is a leaf node. That is why I have given the condition as root dot left equal to null and root dot right is also equal to null. And when that sum value is equal to the target sum, we have got the path sum value. So if it satisfies all the three conditions, we have got the path sum will return true. So here root dot left is 200, that is not equal to null. So condition becomes false. I will not go inside the if condition. So what I am going to do is, from this particular node, I am going to the left child. So I am calling a recursive call for the left child. So I am calling a method called helper, okay. Root dot left, root is pointing to 100, root dot left is 200. So I will be giving 200 here. And target sum is 22 and sum. So in this method, sum value was 5. So I will be passing the sum value as 5. Which means now helper method is pointing to the node called 200. Fine. So again I'll come to the method called helper again. Root is 200, target sum is 22, sum value is 5. Now check whether root is equal to null. Now root is pointing to the memory location called 200. Condition becomes false. Now what I have to do? Sum equal to sum plus root dot value. Sum value is 5, sum plus root dot value. So root dot value is 4. 5 plus 4, 9. Now sum value has been updated as 9. Now check whether this is a leaf node. Condition becomes false. So what I have to do? I have to go for the left child. So I will be calling the recursive function. So for the left child, I am calling a method called helper. Okay, helper root dot left. Root is pointing to 200. Root dot left is 400. Okay. So root dot left is pointing to the location called 400. So helper will have a value called 400. Target sum value is 22 and sum value is 9. Which means now I am calling a recursive call. Root is going to point to the node called 400. So in this method, now root is pointing to the memory location called 400. So now check the condition, root equal to null. No, root is not equal to null. Sum equal to sum plus root dot value. Sum is 9. 9 plus 11, that is 20. Fine. After this, check whether it is a leaf node. No, this condition becomes false because root dot left is not equal to null. It is pointing to the memory location called 700. So condition becomes false. I will not go inside the if condition. I will go to the left child. So left child address is 700. So I will be calling one more recursive called helper. Root is 700, comma target value 22 and sum is 20. So I am calling the recursive call. So I will go to the node called 700. Now check whether root is equal to null. No, root is pointing to the memory location called 700. Condition becomes false. So I will go to the next line. Sum equal to sum plus root dot value. Sum is 20. Root dot value is 7. 20 plus 7, 27. Now sum value is 27. Now what I am going to do? So in this function, the sum value was 5. In this function, sum value is 9. In this function, sum value is 20. Now when I come to this function, the sum value is 27. Okay. After this, what I have to do? I have to check whether root dot left equal to null. Yes. Okay. This is a leaf node. And root dot right is also equal to null. Yes, it is equal to null. And sum equal to target sum. Sum value is 27. Target sum is 22. Condition becomes false. Which means this path doesn't give the target sum value. This path doesn't give the target sum value. So the if condition becomes false, I will go to the left child. So when I go to the left child, I have to call a method called helper. Helper root dot left. Root is pointing to 700. Root dot left is null. So null, comma target value 22, sum value is 27. Now call the function again. Root equal to null? Yes, root is equal to null. If root is equal to null, I'll come out of this function, because root is equal to null, I'll come out of this function that returns a value called false, which means when I call the left child of this particular node, root is equal to null, so this returns me a value called false. Okay, where will it return? In the previous method's left child. In the previous method's left child, it will return me a value called false. In this particular method, I have called the left child now, and that has been returned the value as false. That will be stored in the variable left. I am going to call the right child now. So to the right child, what is the value I have? Null. So again I am going to call a method called helper. Right child value is null. Target is 22. Sum is 27. So when I call the right child, check root equal to null. Yes, root is equal to null. So condition becomes false. I will come out of this function and this returns me a value called false. Where will it return? In the previous function. In the node 700, that function, it will return false. For the right child, so this right child, it will return false. Now return left or right. So left is also false, right is also false. So this method completely, which is the helper method with the node 700, completely returns me the value called false. Where will it return? In the previous method's left child. In the previous method's left child, it will return the value called false. So this completely returns the value. In the previous method's left child, it has returned me the value called false. Now here left I have got false. Now I have to call the right recursive call. So in this node 400, I have to call root dot right. So I am going to call a method called helper 400 comma, what was my sum value? My sum value is 20, because in this method the sum value, sorry, the address is 800. Address is 800 and target value is 22 and sum value is 20, because in this method the sum value is 20. How come it is 20? 5 plus 4, 9, 9 plus 11, 20. The sum value is 20. I'll be passing, which means in this method left child I have called and is return value called false. Now I am calling the right child, that is why I am giving 800. Now when I go for the method, I will be checking whether root is equal to null. No, root is not equal to null, because root is pointing to the memory location called 800. That is not equal to null. I will take the sum value. Sum equal to sum plus val. Sum value is 20 here. 20 plus 2, 22. So now sum value becomes 22. So in this method, sum value becomes 22. Now check root dot left equal to null. Yes, root dot left is equal to null. Root dot right equal to null. Yes, root dot right is also equal to null. Okay. Now check sum equal to target sum. Sum value is 22 and target sum is also 22. Condition becomes false, true. So this condition becomes true. So when this condition becomes true, what happens in the sense, from this function directly it returns the value called true, which means from the function helper 800, it returns a value true to the right child of helper 400. So this will return true. This will return true to the right child of the method 400. So it will return true to this particular place. It will return true to this particular place. In this method, left child is false. Left child is false. Right child is true. So here what I have given? Return left or right. False or true. It will return the value as true, because according to R, if any one of the condition is true, that has to return true. So what I have to do? This method return 400 will return me a value called true to the left child of this. Will return true to the left child of this. Similarly, when I go to the right child, so it will return the value, which means I will come out of this method, and then this also returns me a value called true to the helper node 200. In this left child, I have the value called true. When I go for the right child value is null. So again, I will call the recursive call helper null comma 22 comma sum value is 9. So 9 will be passed. Now when I call this method, root equal to null, condition becomes false. So here I will be returning a value called false. So in the left child I have got true, right child I have got false. So here return left or right, false, true or false. Condition is true, because according to R, any one of the conditions is true, that is true only. So this will return me a value called true to the left child of this node. So this will return false and this will return true. So it will return true to this particular node. In the left child of the node 100, it will return true. Now I'll go for the right child. Okay. So similarly, it will be calling the recursive call. Whatever happens when it comes to this particular node, even though if it returns false also, that doesn't matter. It will consider the final value as true, because here in case, let's assume this is giving me the value called false. Okay, this is giving me the value called false. Now when I go to the final statement, return left or right. So left is true, right is false. True or false, output is true only. So from this method, I'll be returning a value called true to the main method, and I'll print it as a path sum. So final output will be true, which means the path is this one, this one, this one, and this one. So gives me the target sum value 22. Okay, this code can be altered. So how come I can alter this in the sense, instead of writing like this, okay, I can write it in this way, which is helper root dot left comma target sum comma sum, or helper root dot right comma target sum comma sum. So instead of taking two different variables, what I can do directly, I can, instead of these statements, instead of these, directly I can write it this code alone. The reason, because I have left child separately I'm calling, I'm storing, right child separately I'm calling, I'm storing, and then I'm returning. So in this case, if the helper dot root dot left, if the left child is returning true, directly I can return true, which means in this stage. So let me undo this. Okay, let me do like this. Yeah. So in this stage itself, directly I'll return true, because left child I've got the value true. I don't want to check for the right case, because according to logical OR, if the first condition is true, it will not check the second condition. So directly I can return true from this statement. It still saves time. Without checking the right child, I can directly return the value true. This code will check the right child also, and then it will return true. If you are writing the code in this method, it will check the right child and then it will return true. So here you can save some amount of time. That's all. Now let's go for the implementation of the code. So here I will be giving return helper root target sum, and then sum value is 0. Now let's define the method public boolean helper. So here I have to pass three nodes: tree node root, int target sum, int sum. So here first I have to give the base condition. So let me write the base condition. If root is equal to null, directly I can return false, saying that we don't have the path sum. If not, I have to add the sum value, sum equal to sum plus root dot val. Now check whether we have reached the path sum. So how come I can know? If root dot left is equal to null, or root dot right equal to null, this is a leaf node, and whether I have reached the sum value, so target sum. So sum equal to target sum. If the condition is true, I will return true. Fine. If not, I am writing the modified code. Return helper root dot left target sum comma sum, left child or the right child. So helper root dot right comma target sum comma sum. So this will help us to know if in the left child if you have got the target sum, directly return true without checking the right child. This is a modified code which I have discussed in the tracing part. Now let's run the code. Now I'll return sum equal to sum plus root dot val, root dot left equal to null. Okay, this is not or, and. There's a mistake I have made here. To be a leaf node, left child also should be null and right child also should be null, and it should meet the target sum. So I have to give and, so that it satisfies all the cases. Let's run the code now. As it passes test cases, let's submit the code. as it passes all the test cases. That's all.